I am Vincent Carbaol from CLS, and I am Head of Satellite Imagery and Drones Activities at CLS. Satellite SAR images are key technologies for a number of maritime applications, ranging from oil detection, whether released by polluting vessels, platforms, or seeping from the seafloor, targets detection, targets being, for example, vessels, icebergs, or even the measurement of mid-ocean conditions, for instance, ocean winds, swells, and surface currents. We will focus a little bit on oil spill detection at sea using SAR images, a technique that has been used over the past 10 years by the so-called European Clean Seanet Service, operated by EMSA, the European Maritime Safety Agency. So why using SAR? The synthetic aperture radar, commonly referred to as SAR, is an active instrument operating at microwave frequencies. It can image the ocean surface during night and day, and it is not affected by the cloud cover. And this ability to provide a maritime situation under any circumstances is a key advantage when compared to optical imagery. The high resolution and the large swath of satellite SAR imagery makes it a unique tool to precisely detect and map oil spills and vessels over large maritime areas. Radar systems operate in L-band, which is good for wave detection, for instance, or in X-band, which is good to get high resolution for ship detection. But generally, for the oil spill detection activities, we use C-band radar like the European one Sentinel-1 or the Canadian RadarSat-2, which is a good compromise for all the maritime applications. So how does it work? The SAR instrument measure the signal intensity that is backscattered from the ocean surface and uses the Doppler history to synthesize high resolution in the along track direction. When imaging the ocean surface, the signal that is backscattered from the sea surface contains information about the level of roughness of the sea surface, which is mainly driven by the local wind speed and direction with respect to the line of sight of the radar antenna. So generally speaking, the intensity of the backscattered signal increases with wind speed. The SAR instrument has a unique ability to capture a wide panel of large-scale phenomena such as oil, waves, fronts, rain cells, etc. Not directly, but the way these large-scale phenomena contribute to modulate the sea surface roughness, which is actually seen by the radar instrument. So, how does SAR image oil spills? We've just seen that the SAR instrument is sensitive to the sea surface roughness, more precisely to wind-generated centimetric waves, sometimes referred to as Bragg waves in a Bragg resonant scattering mechanism. As oil is a viscous matter, when there is an oil spill, the centimetric surface waves are damped and the backscattered signal that is returned to the SAR instrument is decreased, which results in darker areas on SAR images.